Hey, we're back with some roots and radicals, a couple extra examples here to help you along the way in case you need it. Again, by this time we've probably talked a lot about taking the square root of a number, what it means to be a cube root, or even in more generic terms, an nth root. You know, anything with a fifth root, 10th root, uh, things like that. So you can see here I've got a couple examples on the board here. These are kind of more basic type examples where our numbers are going to work out pretty well for us. You can see in the first one here that we've got the square root of 16 x squared y. So again, we're looking at the square root. How do we know it's a square root? Because we don't have an index next to our radical symbol. That symbolizes the fact that we've got the square root. And again, we know the square root of 16 is 4. If not, we're able to figure that out on our calculator using our square root key. When it comes to variables, again, as we've talked about in the previous notes and in class, is that an easy way to take a look at your variables is to take the index. In this case, our index is 2. Take that index and divide it into the exponent of each variable. In this case, the 2 and the 4. And if it divides evenly, then those are perfect squares or perfect roots, and you're all set. So I can take my index of 2, divide it into my power of 2, and I come out with x to the first. I can take my power of 4, divide that by 2, that gives me 2, and so I've got y squared. And so I know the square root of 16x squared y to the fourth is nothing more than just 4x y squared. Cube root. Again, same thing applies with our index in each of our variables. If I need to do a cube root on a calculator, more than likely what I'm going to need to do is this. I'm going to hit the number 3. I'm going to hit my second key, which is usually in the top left-hand corner. And then there's like a little arrow button. We call that a caret. Usually we use that for exponents. And so what's going to happen is on your screen you're going to see this. And so what that tells you is you're now taking the third root of whatever number you're about to type in. So at that point I could type in 27. It'll look like this on your screen. And then it'll come out and say, hey man, that's 3 once you hit enter. For my variables, again, hopefully they will divide evenly. Sometimes they will, sometimes they will not. So I can take my index of 3, divide that into 6, and I get 2. I can take 3 and divide that into 12 and come out with 4. So far so good. Everything's worked out kind of nice and easy. Anybody have any questions yet? No? Okay, well we'll keep going. So in example 3, we're now looking at the fourth root of 256x to the 8th. So again, I can apply the same thing that I just showed you here with your calculator, but now just change this 3 to a 4, and now you're taking the fourth root of whatever number. In this case, 256, which we're going to find out is 4. Take that 4, my index, divide that into my exponent of 8, and I get x squared. And so everything in all 3 examples works out nice and even, which is great, but that's not always going to be the case. So if you need to, stop, rewind, go back, listen to the explanation of the examples again. We're going to stop for a second here, and we've got some other examples that are slightly more difficult for you. All right, so you see we've got 2 examples here. One's a square root and one is a cube root. Right away, if I go into my calculator and try to take the square root of 24, it's going to give me a decimal answer. That's not what we're looking for. Hopefully by now we've talked about how to simplify a radical. In this case, we're talking about a square root. I want to try to find factors of 24 that I can take the square root of evenly. So you start going through 1 and 24, 2 and 12, 3 and 8. Hopefully at some point we come up with 4 and 6. I can take the square root of 4 and that's 2. I cannot take the square root of 6 evenly, and my factors of 6 are just 2 and 3, which are not perfect squares either. So what's going to happen is I'm going to set up a square root symbol kind of behind my 2. The number I could not take the square root of goes back underneath my square root symbol. Again, our index is 2. We want to divide that into each of our exponents. So I know that 2 will go into 5 2 times with 1 left over. So that 1 that's left over is going to be a power on my x that's going back underneath my square root symbol. My index of 2 goes into y to the 4th power evenly as y squared. And so this ends up being my final answer. 2x squared y squared times the square root of 6x. So whatever you can square root evenly should go outside my square root. Whatever I cannot square root evenly, or whatever's left over, goes back underneath my square root symbol. The same thing holds true for cube roots. I want to look for a number that's a factor of 16 that's a perfect cube. I get 1 and 16, 2 and 8. All right. I know that 8's a perfect cube. How do I know that 8's a perfect cube? Because when you break this down, it's 2 times 2 times 2. You see 3 2's, you see 3 of any factor, and I know that's a perfect cube. So I know the cube root of 8 is 2. Again, I'm going to set up a little cube root symbol behind that. Let's kind of make that a little bit neater for you here. So now I focus on my exponents again. My index of 3 goes into 6 2 times. My index of 3 will divide into 14. That will divide into 14 4 times. That's going to give me 2 left over. Again, going back to my numbers, can't forget about that. I had a 2 left over right here, so that's going to go underneath my cube root symbol as well. So again, whatever you can take the cube root of goes outside. Whatever's left over goes back in the box. Kind of like when you've got some takeout from Applebee's or maybe some Chinese food. Take out what you want, you eat it. Whatever's left over, you put it back in the box, put it back in the fridge. So if that helps out, fantastic. But those are some extra examples, and if you have other questions, see me in class. See you then. Bye.